Exponents and compounding periods. In this video, we're going to discuss problems that will help us use the compound interest formula in the next video. So it's really important to understand these two components in order to apply the compound interest formula. Compute. Round your answer to 4 decimal places. Here we have 1.009 raised to the 48th power. This means that 1.009 is being multiplied to itself 48 times. Now, if we were to do this by hand, that would take a really long time. So we need to use our scientific calculator and the exponent key on our calculator to find this value. Most calculators require you to type in the base, which is this number, 1.009, then the exponent key, and the exponent key on some calculators look like an upward facing arrow, or sometimes they have x to the y with a little y in the upper right corner, or y to the x with an x in the upper right corner. And some calculators have EXP, which represents the exponent key. So we can type in the base 1.009 and then select our exponent key. My calculator uses the upward pointing arrow. And then we'll type in the exponent, which is 48. And then push equals. When you do that calculation on your calculator, you should get a really long decimal, which is 1.53736144. And we want to round to 4 decimal places. So we're going to round this 3. And we'll look at the number next to the 3, which is a 6. Since 6 is greater than 5, we'll round the 3 up to a 4. And our final answer is 1.5374. Find the interest rate per compounding period for an account that has an interest rate of 18% per year and is compounded monthly for 6 years. The interest rate per compounding period is represented by the letter I. I equals the interest rate per year divided by the number of compounding periods in a year. First, we'll identify the interest rate per year. The problem tells us that there is an 18% interest rate. We need to convert 18% to a decimal by dividing by 100, and we get 0.18. So we'll substitute 0.18 into the formula, and we'll divide that by the number of compounding periods in a year. The problem tells us that the amount is compounded monthly. Monthly means 12 times a year, since there are 12 months in a year. So the number of compounding periods in a year is monthly, which computes to 12. Now all we have to do is divide 0.18 by 12. And when we do that calculation, we should get 0.015. This is our value for I. I represents the interest rate per compounding period. Interest rates are written as percentages, so we need to multiply 0.015 by 100 to write a percent. This gives us 1.5% and is our final answer. Find the number of compounding periods for an account that is compounded quarterly for 12 years. The number of compounding periods is represented by n, and that's the total number of compounding periods for the length of the loan or investment. The formula for n equals the number of compounding periods in a year times the number of years. For this problem, we have an investment that is compounded quarterly. So quarterly is our compounding period. That means that it's compounded 4 times a year. So the number of compounding periods in a year is 4. And we'll multiply that by the number of years, which is 12. N equals 4 times 12. And that is 48. So there are 48 compounding periods for the account.